Part 4 of section 5.4 is on inverse trigonometric functions. If the sine of theta equals k, then theta is the inverse sine of k. So in this case, we're trying to find out, well, what was the angle if we're given the sine? What angle could that be? And we have for cosine the same thing, and for tan the same thing. There's no notation here for finding our theta. Now, we'll be using calculator at first, and note that the interval, it will return for us. So when we do this to determine what is theta, it's going to be in this interval for sine from negative pi over 2 up around to pi over 2. For the cosine, it will go from 0 to pi, and the tan is same as the sine, negative pi over 2 to pi over 2. So for the reciprocals, this is what we do. So sine of theta is inverse sine of k. If the sine of theta is k, then we can take the inverse sine of k and get theta. Well, what about the other three? Well, it's not just 1 over the inverse sine of k. It's this inverse sine of 1 over a. So if the inverse cosecant of a is the same as the inverse sine of 1 over a, and likewise for secant and for cotan. So we'll get some practice with that with example 4. We're supposed to approximate the acute angle theta to the nearest 100th of a degree and then to the nearest minute. So we'll have to do a conversion there for that. Okay, let's see. Get this straightened out. All right, the sine of theta. So this is just a regular sine one. So you have this key on your calculator, so no worries about that. Above sine, cosine, and tan are the inverses. Inverse sine, inverse cosine, inverse tan. This is not the same thing as the reciprocal, right, function. This isn't called an inverse. And it's kind of like when you think of the inverse function when we were determining the inverse function. Remember, for example, the exponential is the inverse of the log function, that sort of thing. That's what we mean by the inverse of the sine. All right, so if we know that the sine of theta is 0.6612, well, what's theta? Well, we can find that by calculating the inverse sine of k, 0.6612. All right, look on your calculator. So we have to turn it on. Our second key, and then the sign. Notice it has sign with the -1 there. Now we type in 0.6612 and see what we get. And we didn't get the right answer because, guess what? We have to have this in the right mode. What mode are we supposed to be in? Degrees. I didn't check my mode, and I can tell right now it's not correct. So let's do that. Let's go back. Degrees. See, it's in radians. Go to degrees. Try it again. Sine is already typed in there. Let's see if it'll work. Aha! Now it works. So we get 41.39. We're supposed to go to 2 decimal places here. So 41.39 degrees, but then it also said to the nearest minute. So we know how to do that. We come over here, 0.39. I know it's going to be to the nearest degree is 41 degrees, but to the nearest minute, I've got to multiply 0.39 times 60. I get 23.4. It didn't say go to seconds, just minutes. 0.4 is not a full, doesn't round up to another minute, so I would just say 23 minutes. Inverse sine. Likewise, we have a cosine problem now. Inverse cosine of 0.8, what would that angle be? So, second cosine, 0.8, and what do we get? 36.87 degrees. 36.87 degrees, going to 2 decimal places. Hopefully you got that. And now let's find out what that is in minutes. 36 degrees, 0.87 times 60 gives us 52.2, 52.2. And again, that doesn't round up to 53, so we'll say 52 minutes. All right, so this is mainly a calculator problem, right? Tan, clear. So second tan, and we're supposed to put in 4.91. So the inverse tan is giving us what was theta if the tangent was 4.91. So tan inverse of 4.91, and what did we get? 78.49. 78.49 degrees, which would be 78 degrees, and let's see how many minutes. 0.49 times 60, 29.4, so that would be 29 minutes. Cosecant of 11. Okay, now this is what we have to look back because this is new to us. Cosecant inverse of 11 is equal to which ones? Sine inverse of 1 over 11. Remember, it was 1 over a. All right, so what is that? Second, sine 1 divided by 11. What do we get? 5.22 rounded. 5.22 degrees, and that 0.22 times 60 will give us how many minutes? 13.2 minutes, so we'll write this as 5 degrees, 13 minutes. Okay, secant, this inverse secant of 115 will tell us what theta is. And of course, we don't have a secant button, but we have a cosine, inverse cosine, and we can just write it like this. Don't be afraid to write 1 over 1.15. Looks a little funny, but it's okay for a calculation. Second, cosine 1 divided by 1.15. Enter. 29.59 to the nearest hundredth of a degree, and 0.59 times 60, does that come out to be 35.5 or 36, 29 degrees, 36 minutes. And the last one, cotan inverse of 0.361 will be the same as the tan inverse of 1 over 0.361. Inverse tan, 1 divided by 0.361. We get what? 70.15. That's probably good. 70.15 degrees, and that 0.15 will give us how many minutes? That's exactly 9, isn't it? 0.15 times 60. So we get 70 degrees, 9 minutes. Okay, so what we're learning new here is the inverse inverse functions for the trig functions, and how to do the reciprocals, the last 3 here. Okay, that's the end of this part.